In this video, I'll be going through paper 2 of the November 2024 Cambridge iGCSE additional math paper, syllabus 0606. So for this paper here, calculators are allowed, total marks is 80, and remember if the answer is non-exact, correct it to 3 significant figures for everything except for angles in degrees where you correct it to 1 decimal place. Okay, unless otherwise stated. Okay, second page of the paper is the mathematical formula which you will be given, okay, for each paper. Okay, so with that, let's start off with question 1. Question 1 is a proving question for trigonometry. Alright, so show that tangent theta plus cotangent theta can be written as secant theta cosecant theta. So we know that the similarity between tangent, cotangent, secant and cosecant is they can all be written in terms of sine and cosine in some ways. So let's start off with tangent theta plus cotangent theta. And we know that tangent theta is sine theta over cosine theta. And cotangent theta is essentially the reciprocal of tangent theta, so it's equals to cosine theta over sine theta. Next, I'm going to make that into a single fraction, so it will be cosine theta, sine theta. Then for this sine theta here, I'll multiply by another sine theta, so it becomes sine square theta. Then for here, I'll multiply it by cosine theta again, so it becomes cosine square theta. Okay, so now I have sine square theta plus cosine square theta, which from here I know is equals to 1, right? Because sine square A plus cosine square A is 1. Sine square theta plus cosine square theta is equals to 1. So this is equals to 1. Okay, next I'm going to split this into 1 over cosine theta times 1 over sine theta. And 1 over cosine theta is secant theta, and 1 over sine theta is cosecant theta. So I have shown that tangent theta plus cotangent theta is equals to secant theta plus cosecant theta. Moving on to question 2, you are given that y equals to tangent x minus x, and you are asked to find dy dx and write your answers in terms of x. So there are two parts, right? You first need to find dy dx and make sure that your answer is in terms of tangent x. So let's do it. So if I have y equals to tangent x minus x, then dy dx will be equals to, when I differentiate tangent x, I get secant squared x. Okay, minus when I differentiate x, I get 1. Now, I need everything to be in terms of tangent, so I need to change this secant square to tangent. So based on our identity here, I know secant square A is 1 plus tangent square A, so I'll change my secant square x into tangent square x plus 1. So this secant square x is tangent square x plus 1. Then there's still this minus 1. Okay, 1 minus 1 is cancelled off. So all is 0. So therefore dy dx is equals to tangent square x. Okay. So with that, you are asked, hence find integration of tangent square x dx from 0 to pi over 4. So recall, if you differentiate y, you get dy dx, right? And if you have to integrate dy dx, let me write this first. So if you differentiate y, you get dy dx, and if you have to integrate dy dx with respect to the x, you'll get y plus an arbitrary constant. Okay, but this is a definite integral, there won't be any arbitrary constant. So I know that tangent square x is basically my dy dx. So if I were to integrate tangent square x, I will get back y, which is tangent x minus x. So let's do it. So this is my dy dx. So when I integrate dy dx, I get y. Okay, and because this is definite integral, so I need to sub in 0 and pi over 4. Okay, so it will be tangent pi over 4 minus pi over 4 minus tangent 0 minus 0. Tangent 0 is equals to, use your calculator, is 0. Then this is also 0. So this whole thing is 0. Okay, tangent pi over 4 is a special angle is equals to 1. Okay, you can also use your calculator, you give a value of 1. So the answer is 1 minus pi over 4. Okay, you leave this as the final answer because the question says give your answer in exact form. Alright. Okay, let's move on to the next question. So this is an indices question for part A, and part B is a surd question. So for part A, let's do it. You're asked to solve this. 8 to the power of 1 over x minus 2 times 8 to the power of negative 1 over x equals to 1. So for this type of question, I will let y equals to 8 to the power of 1 over x. So if you have 8 to the power of minus 1 over x, it is the same as 1 over 8 to the power of 1 over x, right? Okay, because if you think about it, if you have a negative power just means it becomes 1 over what it was. Okay, so if y is 8 to the power of 1 over x, okay, then 8 to the power of negative 1 over x is 1 over y. So 1 over y equals to 8 to the power of negative 1 over x. So I'm going to sub y in. Okay, so this 8 to the power of 1 over x becomes y. Then this 8 to the power of negative 1 over x becomes 1 over y. Okay, so I have y minus 2 over y equals to 1. I'm going to multiply everything by y. So I have y times y is y squared. 2 over y times y is 2. 1 times y is equals to y. Okay, but I want everything to be on one side. So I'm going to bring it over. So it becomes minus y equals to 0. And again, I want to put y first before the minus 2. I'm going to swap it. Okay, so now with that, I can solve for this. I'm going to factorize it. So I have y equals to 0. 1 over it is 1, 1 over it is 2. Okay, so in other words, right, I have y plus 1 equals to 0 or y minus 2 equals to 0. So y is equals to 2, y equals to minus 1. Okay, and remember we are not solving for y, we are solving for x. So 8 to the power of 1 over x equals to negative 1, which rejects since 8 to the power of 1 over x is more than 0 for all real values of x. Recall your a to the power of x graph. It will either look like this if a is more than 0. Sorry, if a is more than 1, this is y equals to a to the power of x. Okay, if a is lesser than 1, this is how it looks like. But no matter what, the y will always be greater than 0. It will never be 0, it will never be negative. So if a to the power of x is equals to negative 1, we can reject it. That will not happen. Okay, now let's solve this. I know 8 to the power of 1 over x is equals to 2. So how do I find x? I will, there are a few ways to do it. I can change 8 to 2 to the power of 3. Okay, so it's 2 to the power of 3 times 1 over x is equals to 2 to the power of 1. So 3 over x is equals to 1. They have the same base, so the power must be the same. So x is equals to 3. Okay, or you can ln both sides and solve it as well. So alternatively, if you have 8 to the power of 1 over x equals to 2, you can also ln both sides. So ln 2 equals to 1 over x ln 8. Then 1 over x equals to ln 2 over ln 8. Then you can type it into your calculator. It will give you 1/3. So x is equals to 3. Okay, so this is another method. Okay, both will work. Okay, so we are done with 3, which is an indices question. So let's move on to 3b, which is a surd question. So it is given that a minus root 3 squared equals to b plus bracket 3 minus b root 3, where a and b are integers. Find the possible values of a and b. So let's expand it and then compare coefficient. So I expand a minus root 3. Okay, I need to expand on both sides. Okay, so let me expand this. So it will be a squared minus 2a root 3 plus root 3 squared, which is 3. Okay, then b plus 3 root 3 minus b root 3. Okay, so now let's put all the terms. Since a and b are integers, they do not have any cert in them. I know that the next thing I'll do is I'll group all the root 3's together and those without root 3's together. Okay, so let's do, I have 2a root 3 minus 3 root 3 plus b root 3 equals to b minus a square minus 3. So this is root 3. I have minus 2a minus 3 plus b equals to b minus a square minus 3. So in order for this to be equals to this portion must be equals to 0. This portion must also be equals to 0 because a and b's are integers. So minus 2a minus 3 plus b must be an integer. An integer multiplied by square root 3, okay, will never be equals to an integer unless this portion here is 0. So because we also know that because a and b are integer, b minus a square minus 3 is also an integer. This is also an integer. Integer times cert can never be equals to an integer. So the only way for them to be equal is minus 2a minus 3 plus b equals to 0. Or I can write it as b equals to 2a plus 3. Or this one is 0 and this one is 0. Okay, so I can rewrite it as b equals to a square plus 3. So I can solve the simultaneous equation because I made b the subject for both of them. I can equate them. So a square plus 3 equals to 2a plus 3. So therefore, the plus 3 can cancel off because you have plus 3 on both sides. Okay, so a equals to 0 or a equals to 2. Okay, so now that I've written this, okay, I need to find out what is, I found a already, right? So I need to find b. So from 1, b is equals to 2, 0 plus 3, which is 3. Or for this part, b is equals to 2, 2 plus 3, which is 7. So my answer is a equals to 0, b equals to 3, or a equals to 2, b equals to 7. Okay? Okay, moving on to question 4. Question 4 is a vector question. So you're given a diagram which shows triangle OAC, OAC. The point B, which is here, lies on AC such that AB is to BC is P is to Q, where P and Q are constants. Okay, and then they are not equal to each other. Okay, so next I know that OA is A, OB is B, OC is C, and you're asked to show that B is equals to this. Okay, so this is B. So what I'll do is I will first, I know that in order to find OB or B, it is equals to vector A plus AB, right? But how do I find AB? Well, I can't find it yet unless I first find AC. Okay, so I'll first find AC. So AC is equals to OC minus OA. Okay, or you can look at this diagram here. In order to find AC, which is from here to here, I start here, I end here. So it is negative A plus C, or it's C minus A. Okay. Okay, so now I know that I want to find AB, right? Because B is equals to OA plus AB. So if I want to find AB, okay, and I know that this is P units and this is Q units. So AB will be P over P plus Q AC. So I'm going to sub in AC, which is C minus A. Okay, now that I found AB, OB or the vector B is essentially equals to OA, which is A, plus AB, which is this. Okay, so now I'm going to, this is 1 over 1, right? So it's also P plus Q over P plus Q A. Okay, I need the common denominator so that I can combine it. Okay, so I have P plus Q, then P plus QA plus PC minus PA. So this one is P plus QA, this one is minus PA, so the P and the minus P will cancel off. I'm left with QA. So I've shown what the question requires me to show, and since the question writes it as Q plus P, I'll just change the bottom to Q plus P. Okay, now moving on to question 5, you are given log base A, P plus 1 plus all these, and you're asked to find P. So one look at this question, right? The first thing you need to remember is whenever you have different base, in order to do anything, you must first make sure that they have the same base. Okay, so I have base A, base A, base A, base A, but here's base P. So I need to change this to base A. So remember, if I've log, let me use X and Y, and I want to change it to base W. So what do? It'll be W log Y base W over log X base W, right? So I do need to do a change of base for log A base P. Okay, the rest just remain. So 1 over log A base P is equals to, let me change it to base A, right? Because everything else is in base A. Okay, maybe before I do that, let me just do this first. Okay, so I'm going to change log A base P to base A, so it'll be A and P, right? So log A base A is 1, right? So this is 1 over log P base A. Now I've log 1 over log A base P is equals to 1 over this, right? So it is basically equals to log P base A. Okay, so now I'm going to change this to log P base A. So let's do it. So, and remember, next let's apply other rules of logarithm. If I have log A plus log B minus log C, just remember, if it's plus, you can put them, you can multiply them together. If it's a minus, you divide them. So I'll be multiplying P plus 1 times P times 5, then divide by P over 2. Okay, that's how I combine these logs together. Okay, and both of them are log with base A. Okay, so and they are equal to each other. So in other words, this must be equals to 12. So let me expand it as well. 5p squared plus 5p over p plus 2 is equals to 12. Then I'm going to do a cross multiplication. Okay, make one side 0. Okay, next factorize it. (15 minus 8 is 7, so I'll do it this way. Okay, so I know 5p plus 8 equals to 0, or p minus 3 equals to 0. So p equals to 3, or p is equals to negative 8 over 5. But we cannot have, if you look at this, there are many reasons. You cannot log a negative number. You also cannot have a base being negative. Okay, so we can reject, since p should be more than 0 for log PA, okay, to exist. So the final answer is p equals to 3. Okay, move on to question 6. 6 is a circular measure question. So the diagram shows a shape A, B, C, D, E, F. Okay, A, B, B, D, D, E are three sides of a rectangle. Okay, so this A, B, E, D are three sides of a rectangle. That means AE is the other side of the rectangle. So AEDB is a rectangle. Okay. Then O is the midpoint of BD. O is the midpoint of BD. Okay. Then what else? AFE. AFE is the arc of the circle whose center is O. So in other words, this is a sector. OAFE is a sector with center at O. Then AB is root 3. BC is 5 units. And BD is 6 units. So because I know O is the center, right? So here will be 3 and 3. Okay, because O is the midpoint of BD. So BO equals to OD equals to 3. Okay, so now I need to find the perimeter of the shape, give your answers in terms of pi. So what do I need? I already know that there are, let me start counting from A. So there's 1 curved side, then 2, 3, 4, 5. 5 sides that I need to account for. Here's root 3, here's root 3, here's 5, here's 5. The only thing that I haven't found is AFE. So this is an arc. So in order to find an arc length, based on the formula, you can also use your formula booklet. So based on your arc length, it is r theta. Okay, where theta is in radians. Okay, so now that I know this, okay, what do I need to do? I need to find what is the radius, right? And the radius of this sector is basically OE or OA. And in order to find OA or OE, I need to use Pythagoras theorem. So OA is equals to root 3 square plus 3 square square root. Okay, so it's equals to 3 plus 9 square root or square root 12. And if I want to simplify, square root 12 is equals to, square root 12 is basically square root of 4 times 3. So I can square root 4, I can square root 3. Square root 4 is 2, so it's 2 root 3. Okay, so I know OA is square root 3. So next, I need to find this angle here, right? So first thing I'll do is, I know to find angle AOB, I will use tangent inverse. Okay, to find this angle here, I will use tangent inverse root 3 over 3. And this is a special angle, right? It's equals to pi over 6. Okay, or 30 degrees. And I know that angle AOB is equals to angle EOD, which is pi over 6. So therefore, angle AOE, which is here, is equals to 180 or pi minus pi over 6 minus pi over 6. So it's the same as 1 minus 1 over 6 minus 1 over 6, which gives us 2/3, and then there is a pi here. Okay, so now that I found that this is 2 pi over 3 radians, I can find this arc length by taking r, the radius, which I have found, 2 root 3, times 2/3 pi, which is the angle here. So arc length of AFE is equals to r, which is 2 root 3 times 2/3 pi, which will give us 4 root 3 over 3 pi. Okay, so next I need to find perimeter. So recall I said that there are 5 sides to add, right? So let's start off with this arc length here, which is 4 root 3 over 3 pi. Then let me add root 3 twice and 5 twice. So root 3, if I add them twice, it becomes 2 root 3. 5 plus 5 will give me 10. Okay, so I have 10 plus 2 root 3 plus 4 root 3 over 3 pi units. Okay, so this is the perimeter of the shape. Next, you're asked to find the exact value of the area of the shape, giving your answers in terms of pi. Okay, so we need to find the area. So if you look at this, I can cut this into four. I have four shapes, right? One of it is this triangle here. I have this triangle here that I need to add. Then I need to add these two triangles here. And finally, I need to add this sector. So area of sector is half r square theta, right? Area of sector. Okay, so let me find the area of the sector first. The sector, let me call it OAFE. OAFE. So it equals to half times r square. So r is 2 root 3. I need to square it. And theta, the angle is 2 pi over 3. Okay, so I square this. 2 square is 4. Root 3 square is 3. So 4, 3 is 12. 12 times half is 6. 6 times 2/3 is 4. Okay, use the calculator. Okay, then you have a pi here, just add it in. Okay, so I found the area of the sector. Next, I want to find the area of these two triangles. So area of triangle ABO and EOD. Okay, so I have two of them and they are the same, right? So it's half times base, which is 3, times root 3. So the area of each triangle is half times 3 times root 3, and there are two of them, so I need to times 2. So it is half times 3 times root 3, and there are two of them, so I need to times 2. So I'll get 3 root 3 units squared. Okay. Finally, I need to find this area here, the area of this triangle. The problem with this triangle is I do not have a lot of information, right? I do not know what is the angle here, so I cannot use half AB sine theta to find area of triangle. Okay, but what I know is I can find OC. So recall that if you have an isosceles triangle, okay, if you were to draw a line from this point here down and it's perpendicular to this line here, then this will bisect this line equally into two. Okay, so in other words, to find the height of this triangle, I can use Pythagoras theorem. So I can find OC, okay, by Pythagoras theorem, right? So OC is basically 5 square minus 3 square square root, because this is a right angle triangle. So I need to find OC is equals to square root of 5 square minus 3 square. Okay, 25 minus 9 is 16. Square root 16 is 4. So area of triangle BDC, this is C, right? BDC. So I know that the height is 4 units for this triangle. Here to here is 4 units. So it's half times 4 times the base, which is 6 units. Okay, which will give us 12 units squared. Okay, so area of figure, they call it shape, so I call it shape, is basically adding up this, this, and this. Okay, so it's 4 pi plus 3 root 3 plus 12 units square. Okay. Okay, I leave this as the final answer because the question says exact form. Okay, because they ask for exact value. So just keep it as this, and that's the final answer. Moving on to question 7. 7 is an application of differentiation to tangent and normal question. So I have a curve has an equation y equals to 2x cosine x. So because you have 2x and cosine x, two functions in terms of x, if you have to do any differentiation, you will need to use product rule. Okay. The normal to the curve at this meets the x and y axis at P and Q. Find the area of POQ. So you see the word normal, so we need to find dy dx, then find the gradient of the tangent, find the gradient of the normal, then find the equation of the line. So let's first start off by finding dy dx. So you need to use product rule, right? So maybe I'll keep 2x first, then differentiate cosine x, which gives me negative sine x. Then next I'll keep cosine x, and then I differentiate 2x, which gives me 2. So it's basically negative 2x sine x plus 2 cosine x. Okay, next, when x equals to pi, okay, dy dx is equals to negative 2 pi sine pi plus 2 cosine pi. So sine pi is 0. Use your calculator. Make sure that it's in radian mode. This will give you 0. Cosine pi, okay, is negative 1. So it will give you minus 2. Okay, so gradient. So gradient of tangent at x equals to pi is minus 2. So gradient of normal is equals to negative 1 over minus 2, which gives us half. Okay, so now that we have the gradient of the normal, we can find the equation of normal. Basically, if you know the equation of this, if you know the gradient and you know a point, you can find the equation of any straight line by taking y minus the y coordinate of a point, okay, equals to the gradient times x minus the x coordinate of the point that you have, or any point. Okay, but these two must be corresponding coordinates of the same point. Or maybe instead of writing, I can write 5 over 2. Okay, so now I need to find the x-intercept and the y-intercept, right? So when y is 0, okay, I know 0 equals to half x minus 5 over 2 pi. So therefore, x is equals to 5 pi. So therefore, p, which is the x-intercept, is 5 pi comma 0. When x is 0, y is equals to negative 5 over 2 pi. So I know that q is 0 comma minus 5 over 2 pi. Okay, so I have found p and q. So once I found p and q, what do I need to do? Well, I do need to find what is the area of POQ. So O is basically the origin. So let me first mark them out. So this is my O, which is 0, 0, and this is Q. This is Q, right, which is 0 comma minus 5 over 2 pi. And this is my P, point P, which is 5 over pi comma 0. So this is the triangle that we are looking at, right? So the area of the triangle is basically half times 5 pi times 5 over 2 pi. So because from here, O to Q is 5 over 2 pi units. So area of triangle POQ is equals to half times 5 pi times from here to here, which is 5 pi over 2 units, which will give us 25 pi square over 4 units square. Okay, so that is the area of POQ. Moving on to question 8, which is an application of integration and differentiation to kinematics. So a particle moves in a straight line, so that its displacement from a fixed point O at time t is x meters, okay, where x is equals to this and t will always be greater than or equals to 0. Find the time when the particle changes direction. So when it changes direction, your dx dt equals to 0, right? So let's do that first. So I differentiate this, I get 3t squared plus 2t minus 1. So when dx dt equals to 0, particle changes direction. Particle changes direction. So 3t squared plus 2t minus 1 equals to 0. 3t plus 1t minus 1t. So I get 3t minus 1 equals to 0. T equals to 1/3. T plus 1 equals to 0. T equals to minus 1. Reject, since the question already gives us. So therefore, t equals to 1/3 when particle changes direction. Okay. So for this one, right, for this type of question, it's important to be able to interpret the question, okay, what they give. So if you see change direction, that means your dx dt is 0. It changes direction when your velocity goes to 0. Okay, it's instantaneously at rest. Okay, next let's move on to B. Show that the particle is moving towards O when t equals to 0. So how do you know that it's moving towards O? Okay, when t is equals to 0, well, you need to have a negative velocity, okay, in order for it to be moving towards O. Okay. So if v is positive, it means that it's moving away from O. If v is negative, it's moving towards O. So we do need to show that v is moving towards O, okay, by showing that v is negative. So I know that which is equals to v. So I know from part 1 that my v is equals to 3t squared plus 2t minus 1. So when t equals to 0, v is equals to negative 1. Since velocity v is negative, okay, so when it is negative, what does it mean? It means that the particle is moving closer to the reference point. Okay. Okay, and wait, before I do that, I also need to show that x is 8. Okay, so if it's negative, so why I don't need to show that x is positive? This is because, right, this is the reference point 0. So here, this is x, right, as x increases. So if, okay, x is positive and v is negative, it just means that the particle is moving in this direction, okay, in the direction of decreasing x. But if x is negative, maybe it's at negative 8 here, and velocity is negative, that means it's moving away from O also. Okay, so you need to say, since velocity v is negative and x is positive, okay, this means that particle is moving towards O. Alright, okay, you need to talk about this too. Okay, next, find the total distance traveled by a particle during the first 2 seconds of its motion. So I know from part A that it changes direction at t equals to 1/3. Okay, so what I need to do is I first need to find at t equals to 0, I know that x is 8, right? When t equals to 1/3, let's find out what is x. X is 1/3 cubed plus 1/3 square minus 1/3 plus 8. Okay, type this into the calculator to evaluate it. Okay. So 1/3 cube plus 1/3 square minus 1/3 plus 8. So it's 7 and 22 over 27. Okay. Next, I also need to find when t equals to 2. Okay, what is x? So I have 2 cubed, right, plus 2 square. Just sub in x equals t equals to 2 into this. Equals to 2 units. Is it? It's 18 units, sorry. Okay. So now, why do I need this 2? So I need, because this is the starting time, this is the ending time, and I know that at t equals to 1 that it changes direction, right? So to find the total distance traveled, I know at t equals to 0, so this is my O. At t equals to 0, it is here, it is 8 units, right? At t equals to 1/3, it is here. Sorry, here to here is 8 units. Then here to here it's 7 and 22 over 27. Okay. Then after that, at t equals to 2, it is here, right? So here is 18 units, right? From here to here is 18 units. Okay, so what it does is I know that at t equals to 0, it starts off here. Then at t equals to 1/3, it moves towards here. Then at t equals to 1/3, it changes direction. That's what we have found in part A. Okay, so it will change the direction. Then it ends off here. So to find the total distance traveled, we will find this distance first, right? So it's 8 minus 7 over 22 over 27, or just 5 over 27. Okay, which is here. I found this. Then next, to find this distance, it is basically this, which is my 8 minus 7 over 22 over 27, right? So this portion here is 8 minus 7 over 22 over 27. You'll get this. So this portion is 8 minus 7 over 22 over 7. So I'm start here. I've traveled this yellow shaded part. Okay, then I just travel this yellow shaded part here again. Then I travel from here to here. So you know here is 18. Here to here is 18. Here to here is 8. So here must be 10, right? So plus 10. So add together, you should get 10 and 10 over 27 units. Wait, 10, so this one it's 5 plus 5 is 10. Okay, 5 over 27. Okay, so 5 over 27 here. 5 over 27. Okay, so this is the answer for part C. Okay. Okay, so now let's move on to the next question. A curve has an equation of this. Find the value of C in the following cases. So I know that this is a quadratic equation. So find the value of C in each of the following case. The curve crosses the x-axis at 2. So in other words, right, when x equals to 2, y equals to 0. So I'm going to sub this in. So y equals to x squared minus 8x plus c. When y is 0, x is 2. So therefore c is equals to 12. Okay, so that is how I do it. Next, let's move on. The minimum value of y is 3. So what I need to do is, Okay, since coefficient of x squared is 1, which is greater than 0, the quadratic curve has a minimum point. So I know that any stationary point it has will be a minimum point because it looks like this, since the coefficient of x squared here is positive. Okay, so to find the turning point, you can differentiate it or you can complete the square. I would want to complete the square because it's easier. dy dx is equals to 2x minus 8. Okay, so x is equals to, so when dy dx is equals to 0, x is equals 2x minus 8 is equals to 0, so x equals to 4. So minimum point is 4, 3. So this is what I know. So I'm going to sub 4, 3 into the equation. So sub x equals to 4, y equals to 3 into y equals to x squared minus 8x plus c. So I have 3 equals to 4 squared minus 8 times 4 plus c. So from here I know c is equals to 3 minus 16 plus 32. Which is equals to 19. So I know for this part here, c is equals to 19. Okay, another way to do it is by completing the square, so I can show you. Okay, so I have y equals to x squared minus 8x plus c. So to complete the square, I have x minus 4 squared. So I'll divide the coefficient of this by 2 to get 4. Then next, I need to take c minus 4 squared. So I know that the minimum value is c minus 4 squared. So minimum value based on this form is c minus 4 squared. And I know that c minus 4 squared is, like what they say, 3, right? So c minus 16 equals to 3, so c equals to 19. So this is another way of doing part 2. Both will give the same answer. Next, find the range of values for which y is always greater than 0. So we know that this curve looks like this. So in order for y to be always greater than 0, it means that this curve must never touch the x-axis. So there is no real roots for y equals to 0. So in other words, we know that the discriminant is lesser than 0. So let's apply discriminant. So I know it is, the b is negative 8, the a is 1, and the c is basically just c. So c is greater than 4. Okay, where b square, oh sorry, it's not 18, my bad. This should be 8 squared is 64. So this is 64 here. So c is greater than 16. So how I got this is I moved this over. So 4c is greater than 64. So I can rewrite this, right? 4c is greater than 64. It's the same thing. Okay, that's how I got this. Then I divide both sides by 4. So I get c greater than 16. Let's go on to question 10, which is a permutation and combination question. Okay, so a class contains 7 girls and 8 boys. A group of 6 is selected from the class. So you need to select 6 from this class of 7 girls and 8 boys. The group must contain at least 3 girls and at least 2 boys. So at least 3 girls and at least 2 boys. So you can have 3 girls and 3 boys, or 4 girls and 3 boys. So these are basically just the number of cases. So you need at least 3 girls, at least 2 boys, total 6, right? So you have girls and boys. Total must add up to be 6, right? The girls must be at least 3, right? So you can have 3 boys. or you can have 4 girls and 2 boys. So these are the only 2 options that you have. So the number of different groups that can be selected, okay, will be equals to get to select 3 girls out of 7 girls is 7 choose 3. Then to select 3 boys out of 8 boys is 8 choose 3. Okay, so the number of ways for this will be 7 choose 3 times 8 choose 3. For here, to find the number of girls, to select 4 girls out of 7 girls, 7 choose 4. Then to select 2 boys out of 8 is 8 choose 2. And because these 2 must occur simultaneously, you multiply. These 3 girls and 3 boys, 4 girls and 2 boys cannot occur together, so you add. Okay. Okay, then type everything into the calculator. Okay, you should get an answer of 2,940. Okay, moving on to 10b, a 5 character code is to be formed from the following characters A, B, C, D, E, F, and numbers 1 to 3. So no character may be used more than once in any code. The character may be arranged in any order. Find the number of different codes that can be formed using 4 letters and 1 number. 4 letters and 1 number, right? So in other words, number of ways is basically, okay, because I only have 1 way, right? I need 4 letters and 1 number. So let's look at how many ways are there to choose 4 letters. There are 1, 2, 3, 4, 5, 6. 6 letters, right? I need to choose 4. Next, I have 3 numbers. I need to choose 1. Then these 5 letters and 1 number can be arranged in any way they like. So in order to arrange 5 of them, it will be multiplied by 5 factorial. So the total number of ways will be 5,400. Okay. So with that, we have finished this question on PNC. You'll notice that for PNC questions, right, it's typically quite easy. The working that is required is not so extensive compared to the other questions. Okay, so it's usually quite short. So as long as you're familiar with the concepts, right, it should be a relatively easy to score type of questions. Okay. Okay, let's move on to the next question here. So this is a function question. So you're given fx equals to x over x minus 1. So use the diagram to explain why f is a function. So in order for a function, for something to be a function, you draw a line y equals to k, where k is you draw x equals to k, where k is within the domain. Okay, and it will only cut the fx at only 1 point. So that is why it is a function. Take note, it's for asking for function, not 1 function. 1 function, you draw horizontal line. To prove that something is a function, you draw a vertical line. All right. Okay. So this is what you write. The line x equals to k, where k is basically the domain of f, cuts y equals to fx at only 1 point. Okay, so therefore f is a function. Next, you're asked to find f(x) and give your answer in the simplest form. So f(x) is equals to f. Then I'm going to sub in fx, which is x over x minus 1. Then next, I'm going to sub in x as x minus 1 into this f. Okay, so I have x over x minus 1 over x minus 1 over x minus 1. Okay, so essentially I have x over x minus 1 over 1 over x minus 1, which will essentially give me, if you look at this, is a division, right? Division, that means you flip, gives me x. So I know that f(x) is equals to x, and it will take the domain of f. So it will be x is in between minus 10 and 10, where x also cannot be equals to also cannot be equals to 1. Okay, so this is f(x). Okay, using part 2, state the relationship between f and f inverse. Okay, so they want you to use part 2, right? So we know that the relationship between f and f inverse is f and f inverse, they are a reflection about y equals to x. So in this case, they are reflection about f(x), because f(x) is y equals to x. Okay, and because of this, right, so the next thing I know is that, okay, so let me explain first. So I know that f(x) is equals to x, right? And I know that f inverse f(x) is also equals to x, right? This one is always true. This one is only true for this question. When you learn your functions, you know that f inverse f(x) is equals to x, or f inverse x is equals to x. This one is always true. Okay, so now let's look at this. I know f(x) is equals to x, f inverse f(x) is equals to x. So what does it tells you? Tells me that f and f inverse are equal, right? Because this is always true. You don't need to do this question, you know that this is also always true. But from part 2, you know that f(x) is equals to x. Okay, true for this function only. Okay, so what does it mean? They are the same, right? f(x) is equals to f inverse f(x), or is equals to f inverse x. So it means that f inverse is the same as f, right? This is the same as this, or this is the same as this. Okay, so that they are equal to the same thing. Okay, and this is what you need to say for this question. So the answer is f and f inverse are the same. Okay, and that's the answer. Okay, explain how the diagram shows the relationship between f and f inverse. Okay, so basically you just need to say that, okay, so you notice that if I were to reflect this about y equals to x, I get exactly the same thing, right? Okay, so basically just write what you know. F and f inverse are the reflection of about the line y equals to x. Okay, next, a function g is defined by gx equals to x over x minus 2 for x is greater than or equals to 2. Find the range of g. So this is y equals to x over x minus 1. This is gx, x over x minus 1. They are the same equation, right? But the only difference is in the domain. This one is x greater than or equals to 2. This is from minus 10 to 10. So let's take a look at 2. This is 1. So this is 2, right? Okay. So we know that, or I can also sub in when x is 2. 2 over 2 minus 1 is 2, right? So you can see it's roughly 2. So here's 2. Okay, and there's an asymptote here, a horizontal asymptote for x over x minus 1, which is y is equals to 1. It will never cross this value here. So I know that, right, based on this graph here, so when x is greater than or equals to 2, your y will be in between 1 and 2. So you go from 2, which is here, all the way down, but you never cross 1. So it's in between 2 and 1. So the range of G, okay, you can write it as, because it includes 2, so it starts with 2. So it ends with 2. But because of the asymptote, it can never be 1, so it does not include 1. Okay? Or you can write it this way, G is in between 1 and 2. Okay? Next, a function is defined by hx equals to 2x over 3x plus 1. So find for the largest possible domain, state the domain of h. So in other words, right, this can take any value. So I know that x can be all real value except for denominator being 0. So the denominator is 0 when x is equals to negative 1/3. So therefore, this is the largest possible domain of x. So x can take all real values except for negative 1/3. Okay, now let's move on to question 12, which is an AP question. So you have two arithmetic progression A and B, each having 100 terms. Their terms are denoted by A1, A2, A3, all the way to A100, and B1, B2, B3, B4, all the way to B100 respectively. So it is given that A1 equals to B100 and A100 equals to B1, which is equals to 298. So it tells me that the B is going smaller, the A is going bigger, right? So I know that A1, which is the first term, is equals to 1, right? A100 is equals to 298. And I know that the UN is equals to A plus N minus 1D, right? So for AP arithmetic progression A, the first term, which is A1, is 1. Okay, then I know that the A100 is equals to the first term, which is 1, plus N minus 1, N is 100 minus 1, times D, which is equals to 298. So based on this, I can find D, right? So 99D equals to 297. So D is 3. Okay. Okay, so I know that the common difference for A is 3. Okay, now let's take a look at this. I know that B1 is equals to the last term of the progression A, and B100, which is the 100th term, is equals to the first term of the progression. So what does it tell me? It tells me that, right, the B, so if I have to write B1, B2, B3, B4 in terms of A, it will be A100, A99, A98, A97, and so on, and then I end off at A1, right? So in order to do, so if I look at A1 and A100, it's getting bigger and bigger and bigger and bigger and bigger. So the B1, B2, all the way to B100, they are going to get smaller and smaller and smaller and smaller and smaller. And the only way to do so is by having a common difference for B. It's negative 3. Okay? So now I know all this, right? I know the first term of B is 298. The common difference for B is minus 3. The common difference for the progression A is 3, and its first term is 1. So now I know that AN minus BN. So what is AN? AN is basically, let's start off with the first term, which is 1, plus n minus 1, 3, right? Next, I'm going to take bn, so the first term of b is 298, okay, plus n minus 1, negative 3. I basically just sub in the formula for un for AP of A and B. So maybe let me write it here. So for an, okay, an is the first term is 1, right? Then n minus 1, the common difference is 3. For bn, the first term they already gave me 298. Then the common difference is negative 3. Okay? So with that, we can go on to simplify, and they tell us that it's equals to 45, right? So I can find n from here. So just simplify this whole thing. So I know that n plus minus 1 times 3 minus n minus 1 times 3 is basically 6n minus 6. Okay, then this one is negative 297 plus this equals to 45. So let's simplify it. Okay, so it will be 45 plus 297 plus 6 divided by 6. So it goes to so n is equals to 58. So solve for n is 58. Okay. Okay. Next, I'm asked to find the smallest m value such that am is greater than 2bm. So I know that am is basically just 1 plus m minus 1 times 3. bm is basically 298 plus m minus 1 times minus 3. So I want am to be greater than 2bm, right? So let me just write. So I know that 1 plus m minus 1 times 3 is greater than 2 times of this. Okay, basically you just need to solve this one here. Okay, take a look at this first. I'm going to erase this portion, so you can pause the video if you need this part. Okay, I'm going to erase this because I need this space. Okay, so I'm going to solve this here. So I'm going to expand this, so it's 1 plus 3m minus 3 is greater than 298 times 2, which is 596, then times 2 times minus 3, so it's minus 6m plus 6. So I have 9m is greater than 596 plus 6, then plus 3 minus 1, just type everything in the calculator, so it's 604. So m is greater than, divide both sides by 9, 67 and 1 over 9. Okay, so the smallest value of m, so in order to satisfy this equation, and we know that m is the term, right? Is it the first term, second term, third term? It must be an integer. So smallest value of m must be 68 based on this inequality here, because m must be greater than 67 and 1 over 9.